Welcome to homework.
Okay, so we've got this sawhorse projection. And we've been asked to draw various Newman projections of this sawhorse projection as seen looking down this bond here. So I like to color code these. I'm going to call the front carbon green and the back carbon blue. And then before I draw, answer A, B, or C, I'm just going to draw what I see. So I have a starting point off of which that I can rotate around the bond to the various conformations, but while I'm in the Newman projection. So, as I said, in the front, we're going to do a green carbon. Okay, so we're going to have chlorine straight up. Right, I see hydrogen is going to be poking out to the right. And I see chlorine is going to be poking back and to the left. Okay, then we'll do the rear carbon, which is in blue. Okay. And what do we see here? Once again, we still got the CH3 pointing straight up. Right? And our hydrogen, the other two bonds are hydrogen. Right? So it's a hydrogen here and a hydrogen here. Okay. Great. Now, question D, go back to parts A and C and label any steric interactions, energy penalties due to group interactions in too close a space. I think that's kind of, useful to look at before we start answering A, B, or C. Like, what are the interactions that matter here, right? It's the methyl groups and the chlorines, right? If those are interacting in some way, that's going to be some sort of energy penalty for that, right? There's a steric interaction between methyl and chlorine, right? Hydrogen and chlorine, yeah, technically that interacts as well, but that's like, better than chlorine and methyl, right? So the worst thing you can have is chlorine and CH3 in this case, And then we don't know which is totally worse. Let's say medium bad is going to be CH3 and hydrogen, or chlorine and hydrogen, right? And the best, the least, energy demanding is hydrogen, because these are the smallest. Okay, so when we try to build the lowest energy conformation, we want to have the smallest amount of chlorine and methyls overlapping, right? We want to avoid that. Avoid for low energy. Okay, so that tells me that we want to rotate this in such a way that the methyl is, not close to the chlorines. Okay. I'll point something out that currently we're in totally eclipsing, right? That is the chlorine and the methyl are aligned, the chlorine and the hydrogen are aligned, and these two hydrogens are aligned. There's going to be various low energy alternatives that are staggered, in which we rotate, let's say, the back carbon by 60 degrees. So let's just start by doing that. It's actually not going to be the lowest, but it'll be instructive. Okay, chlorine, hydrogen, chlorine, CH3, hydrogen, hydrogen. Okay, right. Is this the best that we can do? Right. We've turned it from being eclipsing to staggered, and now we can kind of look at our interactions and see if we can do any better, right? Well, clearly we've got an interaction between this methyl and the chlorine. This is a gauche interaction, right? Because they're neighboring. They're not eclipsing. This was an eclipsing. Eclipsing is always worse than gauche. Very bad. Gauche is better, right? We still want to minimize gauche interactions between methyl and chlorine, but it's much better than being eclipsing. Okay. So is this good? Can we do any better? Right? If we rotate again and the methyl moves down here, is that going to be better? Well, not necessarily, right? If the methyl is on the bottom, it's going to be interacting with this chlorine, right? And there's one other position we can consider. We can consider rotating to the left. Well, if we rotate to the left or counterclockwise, we're going to put the methyl right here, and it's going to be interacting with both of these chlorines, right? So it looks like we have two equivalent low energy structures. There's this one right here, and then there's what we would get if we rotated it 60 degrees to the clockwise, right? We can't avoid having a chlorine and methyl gauche interaction. We can't totally avoid that. It's impossible. But we can make sure that we have a hydrogen between the two chlorines, right? And there's two different ways we can do that. So this is going to be our lowest energy conformation, right? We can't get any better. We really only have three options, right? There's rotating at 60 degrees to the right or 60 degrees to the left. So this is the best. And what are these interactions, right? We're supposed to label them. Any steric interactions, right? So we've got chlorine methyl, gauche chlorine methyl, and technically, yeah, we have CH3H, we have HH, we have CLH, we have CLH, and we have HCl. Those are all the interactions. Okay, using a Newman projection show the highest energy conformation, right? Well, to be honest, we kind of started with the highest, right? We already said that the worst thing you can have is chlorine next to methyl, and that eclipsing is much worse than gauche. So we started out with a chlorine next, right up on a methyl. And as we know, that all of our eclipsing forms are going to be worse than gauche, but we can still consider that there's three possible eclipsing conformations. We could rotate 60 degrees clockwise or 60 degrees counterclockwise. If we rotate 60 degrees counterclockwise, we're not going to have this chlorine methyl interaction. Remember, we're looking for the worst, so that's not what we want. And if we rotate counterclockwise 60 degrees, then we're going to have a chlorine and methyl interaction, just the same as we do now. And all the other interactions will be the same. We'll still have a hydrogen chlorine and a hydrogen hydrogen. Right? So we already drew the worst, right? So, and the interactions that we have are chlorine, CH3, hydrogen hydrogen, and hydrogen chlorine. But recall, these are eclipsing. These are eclipsing interactions, right? Which are worse than even, like when we look at gauche, it's like, oh, we have 6 interactions. But 6 gauche interactions isn't as bad as the 3 eclipsing interactions. Okay, so that's the worst. We already drew it. The picture they showed us, just by drawing this, that the way they presented it initially, that was already the worst. Okay, using a Newman projection show a conformation of this molecule that is an energy in between that of the lowest and the highest energies, right? So can we draw something that is not as low as this one, but isn't as bad as that one? Yeah, we kind of already talked about it, right? We said that if we rotated this eclipsing one 60 degrees to the right, we'd lose the chlorine CH3 eclipsing interaction. And instead we would just have, well, let me just draw, let's say 60 degrees clockwise, right? What would we get? Still going to be eclipsing. I'm going to leave the front the same, chlorine on the top, hydrogen on the right, chlorine on the left. But now we're going to have a hydrogen here. We're going to have a methyl here. And we're going to have a hydrogen here, right? See how this isn't as bad? Because even though we have an eclipsing interaction, it's between methyl and hydrogen, which isn't as bad as the methyl and chlorine. Hopefully you can see how that's better or worse. And is it better than the gauche? Yes, because gauche is always better. Always better, meaning lower energy than eclipsing. Okay, so we have a chlorine hydrogen. Remember, these are eclipsing strains. We have a hydrogen methyl, and we have a chlorine hydrogen. Oh, from what I can tell, okay, I'm rereading this problem. There's nothing wrong with this. It sounds like they didn't want this better eclipsing one. I just based on the wording of D and the fact that they say you don't need to label anything for part B, which tells me that they didn't want anything labeled for eclipsing, which implies to me that they didn't want eclipsing for part C. What they want is that there's a there's this gauche interaction form, the staggered conformation that is worse than the one we have here, or higher energy. So, right, it was when we talked about rotating this 60 degrees left and putting the methyl between the chlorine. So I'm going to sketch that real quick. That's probably the answer they were looking for. People who write questions aren't perfect. Only people who answer questions are perfect, like me. Okay, so then we put the methyl here, hydrogen here, and hydrogen here. So this is taking this and doing a counterclockwise rotation of 60 degrees. Okay, and we can look and see how this is worse. We have two sets of methyl chlorine gauche interactions, right? In addition to the chlorine hydrogen, hydrogen hydrogen, hydrogen hydrogen, and chlorine hydrogen. Okay, that's probably what they want for C.